Hello, so welcome from the Design Automation Conference 14 in San Francisco. Today I am speaking to an EDA vendor. You know that design and reuse has expanded its scope. We don't have only a website on IPs, but also we cover design tools, which is quite normal because they fit together. Today I have the pleasure to be with a very well-known company now called Onespin. And I am with Dave Kelf, which is a VP of Marketing and General Manager USA. And he will speak about the verification problems in safety critical design, which is quite an exciting topic. Please, Dave.
Thank you. Thank you. Well, yes, so Onespin Solutions is a formal verification provider, which, as many people know, is a new technology for performing advanced verification, providing advanced verification solutions. We've been working, particularly in Europe, actually, with a number of companies there in the space of either automotive or avionics type technologies, and they work on safety critical designs. And safety critical designs are verification, are designs which basically have not just issues in terms of requiring very advanced verification to save costs and to save time, but also, of course, to save lives. So, for example, brake parts in cars, computer and fly-by-wire systems in avionics. We've actually worked with power station companies, nuclear power station companies, on controls for that. Are all these designs where the verification has to be so superior that the design itself can be completely fail-safe. What we've found with these kinds of designs is companies are building in solutions into the chips themselves that allow the chips to recover from faults by themselves. So, for example, they will build redundant logic into the devices so that if parts of the chip itself fails during operation, other parts of the chip can kick in and continue the correct operation. Error correction codes, which essentially allow for, if a bit in, say, memory gets changed or reversed, the chip can self-correct and actually provide the right information. So this is the kind of technology we're now seeing, and it's really the sharp end of verification and requires a lot of very specialized verification techniques. We've discovered that the kind of formal verification engines that we apply can be used to solve these kinds of problems. The things that companies are doing are having to verify first the device in correct operation, and then do things like inject faults into the design during the verification process, and still make sure that the design can then recover from that. So it's almost like verifying the verification, if you like. And again, technically very, very difficult. Formal verification provides an exhaustive verification mechanism. And because of that, we're able to do a much better job of providing an in-depth verification coverage. The solution also allows the coverage of the verification to be tested very carefully. So it provides very clear coverage metrics, which essentially provide back to the user a notion of how much of the design is tested. And the way we were able to do that with formal tools is much more precise than other coverage methodologies. So that's really what we're showing at DAC, is this idea of safety critical designs.
This is very exciting. Many, many years ago, I was a member of the fault-tolerant computing and worked on fail-safe circuits, so very interesting.
Yes, indeed.
Well, thank you very much, and I wish you good luck.
Thank you very much. It's great to meet you.